All right, hello and welcome to day one of our advanced math class for Upward Bound. I just want to start off by saying make sure that you watch the video before this that I posted to Google Classroom. It kind of talks about the breakdown of the class and how things are going to go. And then, yeah, let's go ahead and get right into it. So, and the other thing, make sure that you try to take that pre-test before Wednesday's class. That's actually your homework for our first day, is to take that pre-test. So today we're going to talk about moving from 2 dimensions to 3 dimensions, and we're actually going to talk about it more specific than that. We're going to look at moving from 1 dimension all the way to 3 dimensions. So the way we look at this is I want to first graph x equals 3 on the number line. Well, if this number line is x, 3 is right here, x equals 3 on a number line would just be a point. Okay, it would just be a dot. I have 1 dimension, so I have one coordinate to input, or one coordinate to input. So not too bad. When I graph x equals 3 in 2 dimensions, it's like I've taken this number line and I've stretched it vertically. And I'm going to use a little bit of technology here just to make my line look okay. But what I'm doing is I'm taking this x equals 3 point and I'm stretching it vertically to give myself my second dimension. So my line would end up right here. Okay. And now lastly, if I look at that in 3 dimensions, so if we just think about this logically, it went from x equals 3, went from being a point in 1 dimension to being a line in 2 dimensions. So what does that mean that it should become in 3 dimensions? Well, it should become a plane. So it goes from point to line to plane. And how that looks, it's a little bit tricky to graph in 3 dimensions. But just to look at sort of the breakdown of what we're dealing with here, I have this 3-dimensional coordinate system. That's what this is. And we have to think of our x and y axes. So you see a vertical and a horizontal, just like we saw a vertical and a horizontal before, but they are labeled differently. What we've basically done is we've taken this coordinate grid and sort of laid it down, say, on the table, and kind of spun it 90 degrees. Okay? To where my positive x values are out here, my positive y values are now this way. Okay? And so when we do that, we give ourselves the idea of sort of like length and depth. And then the z-axis becomes our height. Okay? So looking at how we would graph this, remember I'm looking at the idea of x equals 3. So let's look at how we might graph that. So here's 1, here's 2, here's 3. And so I'm just going to try to be as flat as possible here. So this is, if I'm just looking at the xy plane, all I did was I just regraphed this. Now, the thing about this is that there is no stipulation on the z component. So really what that gives us is we would end up with, let me see kind of the best way to draw it to make sense. I don't know if this is the right angle or not, but we would be giving ourselves a plane in 3 dimensions. Actually, yeah. Just to sort of make things a little bit easier, I'm going to go ahead and put this just anywhere up here and anywhere down here. And so to look at this, we now have ourselves a plane in 3 dimensions. Got one that's off a little bit, but that's okay. It is a little bit tricky to graph things in 3 dimensions, especially when you're dealing with a two-dimensional piece of paper, or in my case, just a computer screen here, that does get a little tricky. So it takes some practice. But so this whole plane is just in front of all that other X, Y, Z madness, except for this part. We see this part right here that comes through. That comes through our plane. Everything else would be behind it. Okay, so you have to kind of think, like I said, think in 3 dimensions, and that's sometimes hard for students to do. So that's what we're focusing on. So the next thing that I want to talk about is what would it take. So we just saw that I had x equals 3. Okay, so I was very particular about one value. And when I escalated that through the dimensions, it changed its geometric property. It changed its geometric shape. It went from a point to a line to a plane. So if dictating what one coordinate is tells me what the if I dictate what one coordinate is describes a plane in 3 dimensions, how do I talk about a point? What information do I need? Well, I need 3 pieces of information. I need the x, I need to know what the y is, and what the z is. Okay? And so that's what we're doing here. I want to plot these points on the coordinate plane. So let's see, we'll try the first one in blue here. And when you're plotting in a coordinate plane, it's a lot easier if you give yourself kind of some guidelines. And I'm actually going to make it a dotted line so that we're not too confused. So if I want to look at the point 2, 2, 2, that means x equals 2. So it's somewhere along here. Y equals 2. I want to try to match that kind of angle. And then also z equals 2. So that means it's going to come upwards 2 units. And that's a little bit tough to tell. It's not going to be all the way here where it's even with this 2, because it's technically in front of that. So prospectively, it would end up looking a little bit shorter. And this is where graphing in 3 dimensions gets a little bit tricky. Okay, you might see some people decide to sort of like draw this dotted line to here even, or keep it going the way they had it before and build themselves an entire box. And sometimes that's easy. Sometimes it just complicates things even further. Yeah, I missed that a little bit. That's okay. So this is another representation of how to show something in 3 dimensions. Basically, we just drew a cube where one corner was at 0, 0, 0, and the other corner was at the point that we wanted. So think about that. And how many times have you sat in class trying to draw the perfect cube? I recommend it because it gets your brain thinking about 3 dimensions. And it's not exactly the easiest thing to do, especially if you start looking at, obviously this isn't that good, but if you start talking about, well, I want to do more of a perspective drawing as to like what can I actually see, what pieces of the cube can I actually see, and that changes it even more. Like for me, this is what I can see out of my cube, and that's kind of what I've drawn here, is gone for more of the perspective drawing. Okay, not perfect, but it works. So that's all I'm looking for. I'm looking for you to more have an understanding than to be able to be very awesome at graphing these. It's a bit of a skill. Or I should say it's almost more of an art than a science. That's probably a better way to put it. For the next point, I have 1, 4, 3. So I'm looking along this x equals 1 line, where it meets this y equals 4 line, and where it meets the z equals 3. So that's going to be, again, it's in front of us a little bit, so it's going to be a little bit shorter than that x equals 3, and it's going to be somewhere right in there. So just kind of labeling which ones I'm doing. So this one's in blue, and the second one's in red. Let's do one in green, and then maybe even one in a different color. We'll see. So I want, what kind of green do I got going on here? We'll go with this one. So I want to look at -3, -2, +4. And I'm kind of sad that I don't have any examples here that have a -z. That might have helped kind of put some variance in here a little bit, but oh well, we'll deal with it. -3 on the x is actually right back here. And I'm trying to get to -2 on the y. That's right here. Yeah, I'm not happy with that. What'd you do? Oh, it just switched off. So negative, nope, what am I doing? What am I doing? What am I doing? What did I say? -3 on the x. So again, actually, I'm just going to get rid of all this. Let's just clear ourselves out here so we can see what we're doing. Oop, didn't want to clear that one out, did I? It's kind of the problem with that. The note page is just an object here. So, all right, now we can take a look at it. So again, I'm trying to do this this -3, -2, 4. So -3 is right back here, and I want to bring it across to -2. That should be far enough. -2 is right here. I'm trying to match kind of the angle of those like unit marks. And then up to 4. Now, keep in mind perspectively, this is behind this vertical z-axis. So it's actually going to be taller than this vertical z-axis, and actually by a good amount. I'm not going to say, you know, a ton, but by a good amount, it's behind there. So that point is right there. Let's do one more. The 0, 0, 2, that one shouldn't be too bad. If I were to look at 0, 0, 2, it's 0 on the x, 0 on the y, and literally just up to 2. There are no dashed lines that you'd have to draw. And last but not least, let's go ahead and we'll do it in red. Let me get my line tool in red just to help us out. So the 1, -3, +1. So 1 on the x. I'm being a little bit sort of planning ahead, knowing that I want to get to -3 on the y, and that is right here. And then up 1. Again, it's not going to be all the way to that 1. It's going to be a little bit below it because, again, it's in front of that z-axis. So there's a lot of perspective that we're working with here, and you're forced to when you start looking at 3 dimensions on a 2-dimensional plane. So the next thing we went after is that we saw in the exploration that points in 1 dimension become lines in 2 dimensions, which become planes in 3 dimensions. And we're going to look at that idea and sort of expand on that a little bit. In the past, we've been able to graph lines. That's just something that Algebra 1 classes help us do. So this line is y equals -3 + 4. It starts up here at +4. It goes down 3 and over 1. And we could even do that again, down 3 and over 1. And I don't know, maybe you like to do it one more time. So we get a line that looks somewhat like this. And I'm going to extend it a little ways, if I can. There we go. So we get a line that looks like that. How does that translate to 3 dimensions? Well, pretty easily, actually. The object is going to change. A line in 2 dimensions becomes a plane in 3 dimensions. Okay? So let's look at how we're going to draw that plane. I'm going to graph the same points. I had x was 0, y was 4. So x being 0 means I don't move forward or backwards any. I just go to y at 4. And then 1, 1, this is the point 1, 1, so I'm graphing the point 1, 1, and actually 1, 1, 0. So where those two would intersect would be right in there. Kind of thinking where this point comes from and this point comes from. And then maybe we'll do one more. I don't want to do them all. We had, what is that, -2, 2. So 2, -2. And that's going to be about there. That's the point where that intersects with that. And so we've got these 3 points. Now we can graph our two-dimensional line. Again, just going to use a straight line to kind of help us out. We have a two-dimensional line here, but we're trying to graph that in 3 dimensions. Since we didn't put any regulations on the z-coordinate, it could literally be anything. So we just have to extend this up, over, down, make ourselves a plane, try your best. And the biggest thing I want you to think about is, if you were doing this like that perspective cube, what could you see? And again, the thing that you could see would be, I don't know exactly where it is, but it's this, actually I do, it's right here. The only thing I can see is this positive x-axis after this point, about 1 point something, right? 1.25 maybe, or 1.33. I see that x-axis come out here. Everything else would be behind this red wall, if you will. Okay. One last example, and we'll call it for the day. You could actually skip the two-dimensional side altogether if you wanted to. I find that it helps out a little bit. If I look at where this line goes, it goes through the point -3, 1, 2, 3, and it goes up 2 and over 1. I'll just stick with 2 points just to make it a little bit quicker. So it goes through the point 0, -3, and that's the same idea. This is 0, -3 in 2 dimensions. In 3 dimensions, this is just 0, -3, and it has a z-coordinate of 0 also. Okay. I don't want that there. It's just going to muddy up the waters a little bit. But then it goes to the point 1, -1. 1, -1 is right here. So I'd get another point right in there. And we can graph that line in, words are hard, line in 3 dimensions. And I'm going to have to adjust it just a little bit. Somewhere in there. That's looking a little better. And then I kind of want to plane it off, right? So it's going to come, yeah. Z-axis is always vertical. Let's stick with lines. That looks a little bit better. So z-axis is vertical here, and I do need to try to match this and match this. And then we'll just kind of drag this guy down a little bit, make it look like a true wall, and that is the plane. But again, you could do that without graphing it on the two-dimensional graph, and just remember that you're looking for the y-intercept and how the slope changes. But again, make sure you remind yourself, what can you see? What is the only thing that you can see? The only thing that you can see other than this green wall is this portion of the x-axis. Now, all these were pretty straightforward examples. I didn't have any planes that were behind. I guess if this plane ended here, yes, you could see this also as it's peeking out from behind. But that's all you can see. So think of that perspectively and how that works. A couple of extra examples down at the bottom. Feel free to do those just to sort of help you out and help you see a little bit more of what's happening. That's all for today. Have a good night. We will see you on Wednesday.